Hey, what's going on, guys? Let's do this problem right here. This question is asking to integrate this one using trigonometric substitution. Now let's see how we can do this. But before we do this, we have to know three things. One of them is when we have x square plus a number square, we have to use this one. That is, x is equal to a tan theta, right? Tan theta. And whenever we have x square minus a number square, we have to use x is equal to a sec theta. And whenever we have a square, a number square minus x square, we should use x is equal to a sine theta. So these are the main things we have to remember in order to do these kind of problems. Now if you notice, here we have number square minus x square, because this 25 minus x square is equivalent to 5 square minus x square, right? So we have a number square minus x square. So we have to use the third one. Third one is x is equal to a sine theta. Here we are going to get x is equivalent to a is going to be this number, that is 5. So 5 sine theta, right? Now we can substitute this value for all the x values, but we have to do something about dx, right? To substitute value for dx, we have to take the derivative of this one. Dx is going to be equal to 5. Derivative of sine is cos theta. So this is going to be 5 cos theta d theta. Now we can do the substitution. Now let's go ahead and do the substitution. Here now we have to write everything in terms of theta. Now if you write everything in terms of theta, in the top you are going to have 1 times, instead of dx we plug this 5 cos theta d theta. So this is going to be 5 cos theta d theta right here. And in the denominator we are going to have x square. So for x square we have to square this one. If you square this one, you will get 25 sine square theta. So this is going to be 25 sine square theta. And in the square root we are going to have 25 minus 25 sine square theta. And that's it. Now whenever we have this kind of situation, the first thing we try to do is we try to get rid of this square root. Now let's see how we can do that one, right? Now let's see how we can do this. But before I do this, I notice one thing, that we have 5 right here, we have 25 right here. So we can simplify this one. This is going to be just 5, right? Now let's write the new term. New term, we are going to have cos theta d theta over 5 sine square theta. And then if we take 25 common, we are going to have 1 minus 5 sine square theta. Now, so it's actually 1 minus sine square theta. There's no 5. So this should be 1 minus sine square theta. Now let's see what we can do now. We can take this 25 out of this square root. So if you take this one out, you will get 5 out right here, right? So here we have already a 5, and we can move all the numbers to the front because we are not dealing with numbers when we integrate. So we can move the numbers to the front. So if you move this one, you already have a 5, and if you move this 5 out of this 25 out of this one, there's another 5. So totally we are going to have 1 over 25. And here we have to integrate this one. Now we have cos theta d theta on top, and in the denominator we have sine square theta, and in the square root we have 1 minus sine square theta. Now if you remember, we have this one, sine square theta plus cos square theta is equal to 1, right? So if we want to get rid of this one, this square root right here, we can use this one to get rid of this square root. How we can do this? Because if you notice, here 1 minus sine square theta is equivalent to cos square theta, right? So instead of 1 minus sine square theta, if I plug cos square theta, I can get rid of this square root, right? Now let's continue this one right here. So here we have 1 over 25 and then integration cos theta d theta on top. In the denominator we have sine square theta, and instead of this 1 minus sine square theta, now I am going to plug this cos square theta. So this is going to be cos square theta right here. Now let's eliminate this square root. So we are going to have 1 over 25 integration cos theta d theta over sine square theta cos theta, right? Now if you notice, we can cancel this cos theta and cos theta. So finally we end up with 1 over sine square theta. And sine theta is reciprocal of cosec theta, right? So instead of sine square theta, we can write 1 over 25. So 1 over sine theta is equivalent to cosec theta. So 1 over sine square theta is going to be cosec square theta d theta. Now what's going to be the integration of cosec square theta? If you remember, d over dx tan theta is equivalent to sec square theta, right? And if we have d by dx cot theta, that is negative cosec theta, cosec square theta. So when we have cot theta, that is negative cosec square theta. So if we integrate this one, we are going to get the opposite of this one. Like, this is when we take the derivative. When we do the integration, we are going to have 1 over 25 minus cot theta plus constant, right? So this is going to be our integration. Now our original function is in x form. Here we have in theta format. So we have to bring this one back into x format. To do this one, what we do is we take initial thing, our 5 sine theta, and use this one to write this one in terms of x. Now let's see how we can do this. So let's get rid of this part. So first thing, we have to find what sine theta is equivalent to. Sine theta is going to be equivalent to x over 5, right? Then we have to draw a right angle triangle, and if you put a theta right here, we know that sine theta is opposite over hypotenuse. So opposite right here is going to be x, and hypotenuse right here is going to be 5, right? And if you want to find this missing side, let's say this is a, to find this one, we have to use Pythagorean theorem. We know that Pythagorean theorem is 5 square, hypotenuse square is equivalent to a square plus x square. Here we are trying to find a square. So a square is going to be equivalent to 25 minus x square. Therefore a is going to be equivalent to square root of 25 minus x square, right? So this is going to be our a value. This is our missing side. 25 minus x square. Now what is cot theta? We know that cot theta is reciprocal of tan theta, and we know that tan theta is opposite over hypotenuse. Opposite over hypotenuse. But cot theta is reciprocal of that one, right? So opposite over adjacent is tan theta. So cot theta is going to be adjacent over opposite. So adjacent over opposite is going to be cot theta. Now here the adjacent is 25 minus x square. So we can go ahead and put 1 over 25, and there's a negative sign going to be remaining. And 25 minus x square is adjacent. So that's going to be on top. 25 minus x square, and the opposite side for this one is x. So x is going to be in the denominator plus constant. Now let's go ahead and simplify this one, and we can move this negative to the front. So negative 25 minus x square over x, 25x, right? 25x plus constant, and that's it. This is going to be our final answer. I hope you guys find this video helpful. See you next time.